Alright, so in this one, we're going to graph it, and this is going to have a slant asymptote, and I could tell that right away because the degree of the numerator is bigger than that of the denominator. Now you can actually have different types of asymptotes that aren't just lines. You could have like parabola asymptotes, and that's going to happen when the degree of the numerator is two times bigger than the denominator. So if it was like a cubic over a linear, it'd be that type of asymptote. Alright, so the first thing we're going to do anytime we get a rational function question is we're going to factor everything. So if we factor out the x in the numerator, we get x times x squared minus x minus 6, and then that factors to x minus 3 times x plus 2. And then the denominator, you could pull out a negative 3, and then the remaining part factors to x minus 2 times x plus 3. So we have a couple, so for x-intercepts, so I'm going to make the graph here and kind of add the stuff as I go. For the x-intercepts, those are the zeros of only the numerator, so we have 3 of them. We have one at 0, 0, because of this x right here. We have one at 3, 0, and we also have one at negative 2, 0 for these 3 factors in the numerator. And although they're similar to the factors of the denominator, they're different, so they're their own points. So we have an x-intercept at 0, one at 3, and one at negative 2. And then the y-intercept is also 0, 0, because there's that factor, so because 0, 0 is on the x and the y axis. Alright, and then for vertical asymptotes, those are the zeros of only the denominator. So x equals 2 and x equals negative 3. So we have one like right here, but at x equals 2, and then another one over here at x equals negative 3. Alright, and now we need our slant asymptote. So to find that, we're going to divide the numerator and the denominator using long division. So